In this lecture, we're going to do some advanced Lewis dot diagrams in the Regents curriculum. Let's begin by starting with C2H6, and we're going to start out with carbon. I'm going to draw it out this way. I'm going to assume 6 H's, 3 going to go with each carbon. And the reason why C has more valence electrons, okay, in my early lectures, carbon has 4, okay, and again, if you don't know, we go to a reference table, and we see that carbon right here is in group 14, and if I blow this up and bring it over, we'll see carbon is 2-4, 4 valence electrons. Now, what does that mean? It means it has 4 electrons that it can bond to. It has 4 valence. Put them out there. 1, 2, 3, 4. Lewis dot diagrams are always built upon the valence electrons. So this one has 4. And I put carbon in the middle because I know that it can bond to multiple things. Carbon needs 4 more electrons to be shared with it to have a stable octet. Okay, that octet is a noble gas configuration. So I'm going to put it in the middle. So carbon is the central atom. Okay, and I put 4 dots or 4 valence electrons around this carbon. Now I know that the hydrogen, okay, is somehow going to be bonded with each carbon. Or it has to be somewhat. So I'm going to split this H up. I'm going to put one here. I'm going to put one here. I'm going to put one here. Notice I'm adding one red dot. That red dot is the valence electron for each hydrogen. And that's 3 of them. And of course it kind of makes sense. All of these dots from the carbon, okay, are being shared with a single dot, the single valence electron from the hydrogen. So very simply, okay, by sharing, okay, each carbon in this setup is sharing a total of 8 electrons. It feels stable. This carbon is sharing a total of 8 electrons, and each hydrogen is sharing 2. Remember, hydrogen wants 2 because in the first energy shell there's only 2 electrons. Alright, let's move on. Now you don't need the circles, okay, to complete this. But the circles help us see if the individual atoms have reached their stable number, and 8 for nonmetals is where we're at this level of chemistry. Okay, moving on to C2H4. Same idea. I know my carbons are going to be central, and I'm going to put out the valence electrons. I have 4, so I do that. Alright, the other one has 4, and you certainly don't have to change inks. I'm just doing it so you can see whose electrons are doing what, but essentially in the molecule it doesn't matter anymore. Okay, so hydrogen there is 4, so I'm going to put 2 on each side. And again, it's my guess, and I can change that. There's an H here, it has 2. Let's put an H here, it has 2. Let's put an H here. Now, if I look at this, something should bother me. This electron sticking out doesn't seem kosher. So when I look at this, 2, 4, 6, there's 7 here. I look at this, 2, 4, 6, 7 here. So each carbon is showing a total of 8 by sharing electrons. Each hydrogen is showing 2. That's good, but we have a problem. So we're going to have to, and the only thing you can do is make another bond. So I'm going to take this electron, and I am going to put it right here. Okay, right there. Let's make it black. And I'm going to take the other carbon's electron, and I am going to put it right here. Now, why did I do that? I did that because I needed to add an extra electron. And if you look carefully, draw your circles, you'll see that, my gosh, each carbon is showing 8. So when you run into a scenario where you just don't have enough electrons per the central atom, add another bond, and that'll be the magic elixir to fix that. Now I'm going to rewrite this off to the right, okay? It is perfectly legal, perfectly fine. You won't get arrested if you keep it this way, but carbon makes 2 bonds, 2 dashes, and it makes a bond with an H. And what I'm just showing you is actually how it's going to look like in nature. These electrons would repel themselves into this shape. You don't have to have that here. You could have also written this one as carbon bonded to carbon, and we have more of a four-sided figure for each carbon called a tetrahedral. Okay, whereas this carbon is more of a 120 or 1/3 of a circle, and my honors in AP would call this trigonal planar. My honors in AP would call this sp2 hybridization. Here we'd call this sp3, but my regents folks, don't worry about that. Okay, C2H2, if you notice something, as I'm adding less H's, I'm making more bonds in between. Remember, this is one pair, this is two pairs. Two pairs is two bonds. Okay, in organic chemistry, we're going to call this an alkane. Going to call this an alkene. Maybe if I did it right. An alkene for the double bond. And you probably could guess what's going to happen over here, an alkyne. By regents, folks, there is a reference table Q that shows this. But in any case, let's go back to the Lewis dot diagrams. C2H2. Okay, here comes a carbon, here comes a carbon, and I know that there's 1, 2, 3, 4. Okay, and I know that there's 1, 2, 3, 4. I know that I have two H's, so I'm going to split the H's again. Only way for this to work. Each H brings one valence. The H is happy. Clearly, if you count the central carbon, this carbon has 1, 2, 3, 4, 5, 6. Not enough electrons. And this carbon has the same scenario, 1, 2, 3, 4, 5, 6. So the only thing you can do, party people, is you're going to have to move an electron. And I move that electron here, and I move another electron from the other carbon here, and I'm going to reanalyze each carbon. 1, 2, 3, 4, 5, 6, 7. This carbon has 7. This carbon has 1, 2, 3, 4, 5, 6, 7. Still not sufficient. So the only thing I can do is add another bond. Take that, okay, and move that here. And then take this dot, erase it, and you're going to have to move it. Make sure it's the right color because they're color coordinating here. And what do you have here? You have 3 pairs of electrons. What you have is a triple bond. Okay? And for my AP and honors kids, this sp3 hybridized element has no what? Has no unhybridized p's to double bond, so it doesn't. This being sp has one unhybridized p to bond, and this sp3, sp molecule linear, okay, has 2 unhybridized p's to make 2 extra pi bonds. Okay, we're done with this more advanced, regents level, okay, Lewis dot diagrams.